Anti-patterns concept. Design forces are the competing concerns, priorities, and technical factors that influence the choice of solutions. In anti-patterns, there are two solutions, the anti-pattern solution and the refractored solution. An anti-pattern solution represents a commonplace dysfunctional situation or configuration. The anti-pattern solution may be the result of multiple choices over an extended system lifecycle, or it may have evolved inadvertently. Every solution or design choice yields benefits and consequences. The refactored solution results from a reconsideration of the design forces and the selection of more effective solution, which can be visualized as shown in the figure. The refactored solution yields benefit that outweigh its consequences. There may be related solutions or variations that also resolve the design forces beneficially. Forces in cyber antipatterns. The major types of forces in antipatterns include primal, horizontal, and vertical forces. Primal forces are pervasive design forces present in almost every design decision. Horizontal forces are forces that can apply in all domains. Vertical forces are domain or system specific design forces. The primal design forces in cybersecurity domain include management of functionality, management of confidentiality, management of integrity, and management of availability. It can be visualized from the famous confidentiality, integrity, and availability CIA triad from the IT industry. The functionality design force is added because it drives the other forces. Systems are granted accreditation with respect to a defined level of functionality. Functionality is tested and verified by the developers prior to security testing. Coming to confidentiality. Confidentiality is the protection of information on the system. In most current systems, the information is the primary resource being secured, and the sensitivity of the information defines the level of risk and security priority for each system or the database element. Integrity. Integrity is the protection of coherence of the data and the system metadata. The significant threat of damage to data can be very costly to remediate. This threat affects even the most sensitive systems that have very limited connectivity to external network because data, email, and removable media with malware can migrate to those systems through normal and erroneous operations. Availability. It is the continuous readiness of the system to execute its functionality in response to the users and to the other systems depending on the request, and the ability to continually access its data. Availability is an aspect of the more general concept of quality of service, QoS. QoS is a service level requirement for the system, such such as guarantees of throughput bandwidth or user request response time. To assure the security of a system, testing is necessary evil. A test is comparison of two things, such as a security specification and a system implementation. As a result, requirements for functionality, confidentiality, integrity, and availability should be clearly identified in the system documentation. Cyber anti-pattern templates. It is useful to understand how the templates work and what the fields mean so that you can get the most benefit from them. There are two types of templates. They are the micro anti-pattern template and the full cyber anti-pattern template. You use the micro template for simpler patterns in which detailed explanation will not be necessary. You use the full template for the more complex and more important antipatterns, providing a much more complete coverage of the problem and the solution. The antipatterns which we discussed in our previous lectures are the micro antipattern template. It is a flexible and informal way to present antipatterns. The components of a micro antipattern template are, we have three, namely first one name, second one antipattern problem, and third one refactored solution. The name field. The name of a micro antipattern is usually a pejorative term suggesting the negative consequences of the antipattern's presence. The antipattern problem. The problem section summarizes the micro antipattern symptoms, consequences, and characterization. Refactored solution. The solution section summarizes alternative ways to resolve the antipattern design forces with improved benefits. Because the micro antipattern template is so simple, it can be presented without the formality of templates at all. Full cyber antipattern template. The full cyber antipattern template has two main parts, a header and a body. The header gives a quick sense of the antipattern and the solution, inviting the reader to dive deeper. The body section contains the pattern details. The heading fields in the full cyber antipattern template are as follows. Antipattern name. The name is a unique pejorative noun phrase. The intent is to make this antipattern a well-known phenomenon, easily recognizable with an organizational reputation as an important security gap. Next we have also known as. Many antipatterns are known by various names across different organizations. Some known names or analogous names from different domains are listed here. A given organization might want to adopt a name from this list if their member finds it suitable. Next we have refactored solution names. One or more names of alternative solutions are listed here. The purpose is to give the reader a sense of the direction that this pattern write-up is heading toward and to promote a common terminology for the solution identity associated with the antipattern. Next we have unbalanced primal forces. This field lists the primal design forces that are poorly resolved by this antipattern. And finally we have anecdotal evidence. These are some quips that characterize this antipattern. These phrases are sometimes heard when the antipattern is present and in the early recognition of it. Next we have the body fields in the full cyber antipattern template, which includes first one background. This is optional field, provides contextual explanations that are potentially useful or of general interest but are not central to antipattern and its refactored solution. Antipattern solution. This field defines the antipattern solution through diagrams, explanations, examples, and discussions of design forces. The antipattern solution is a commonly occurring situation or configuration with significant security implications, such as risks, threats, and vulnerabilities. Next, we have causes, symptoms, and consequences. This bulleted section lists the typical causes, common symptoms, and resulting consequences of the antipattern solution. The intent is to make it easier to recognize the antipattern and understand how and why its replacement is necessary. Followed by we have known exceptions. If there are some situations where the antipattern solution might be desirable, this section identifies them. For example, if the consequences are acceptable in a context of if the replacement is not worthwhile. Followed by that, we have a refactored solution and examples. This field defines the refactored solution. The refactored solution is proposed as an alternative to the anti-pattern solution Refactoring is a process of replacing or reworking a given solution into an alternative solution. The new solution resolves the design forces differently, particularly providing a more effective solution that resolves design forces more satisfactorily. And the last one, related solutions. If there are other potential solutions to the anti-pattern, they are identified in this section. Often, there are different approaches to resolve the same problem that don't conveniently fall under the same umbrella of the chosen refactored solution. Cybersecurity Anti-Pattern Catalog. At a high level, this chapter continues this discussion of anti-patterns, cyber mistakes, and bad security habits with these prevalent anti-patterns. First one, can't patch dump. Unpatched applications never read the logs. Networks always play by the rules. Hard on the outside, gooey in the middle. Webify everything. No time for security. These are the 7 anti-pattern catalog that we are going to have a look at. The anti-patterns are intended to be light reading to raise awareness of majority security gaps created by how current practitioners develop and manage the systems and networks. Can't patch dump. The anti-pattern name is can't patch dump. It is also known as social engineering, phishing, spam, spyware, drive-by malware, ransomware, autoplay attacks. Refactored solution names: security awareness, unbalanced primal forces, confidentiality, for example, divulging the private information, integrity, for example, it can be rootkits, anecdotal evidence, technology is not the problem, people are the problem, and the technology is easy, people are difficult. The next field is anti-pattern solution. The end user's lack of security awareness puts his personal information and the organizational competitiveness at the risk. Social engineering, the art of extracting the sensitive information from the people, exploits a human's inherent tendency to want to help other people. Unaware end users are easily fooled into opening malicious email attachments, responding to spam offers, and downloading spyware, ransomware, and malicious websites. The spyware problem is much more widespread than people realize because it involves not just spyware applications but also spyware that is running in the browsers that is served up by knowingly top 100 websites such as ESPN.com and Disney.com. There are thousands of web tracking companies making money spying on your web activities and vacuuming the information from all your browser tabs. About 9,000 malicious websites offer free antivirus solutions. When you install these applications, what do you get instead is a threat and a warning to pay the vendor or your computer becomes unusable. Drive-by malware and computer infections that are loaded automatically when you visit a malicious website. Some of these sites are from legitimate businesses that have been hacked and exploited to download malware. Legitimate websites can also spread malware from their advertisements, which are controlled by third parties. Autoplay infections results when malware is introduced by a user from a universal serial bus or USB memory stick, often in violation of organizational policies. By default, Microsoft Windows autoplays the programs on memory sticks whenever one is inserted. Memory sticks will, with autoplay infections, are distributed accidentally by legitimate companies at trade shows. They have propagated viruses from educational networks to home networks and were used to spread malware attacks such as StuNext. The anti-pattern occurs when the organizations do not take adequate precautions to keep their end users from inadvertently compromising their systems or divulging information to strangers. In the next field, we have causes, symptoms, and consequences. Causes and symptoms of this anti-pattern are a lack of recurring security awareness training program for all the end users, including a test assessment. In the next field, we have refactored solution and its examples. Security awareness training should be mandatory for every person in an organization. Training should be completed before a person is given computer access. And then the organization should conduct annual refresher courses. The courses should include training on social engineering skills as well as internet safety. The training should articulate the organization's policies on what information can be divulged to which group of customers or co-workers. An online training program with integrated testing is ideal and ensures that the required skills are acquired. Test answers can be used for accountability, proving that particular policies were known by specific individuals. And the next field we have related solutions. End users should have a website advisors installed. Perhaps as a part of antivirus suite, users should take even further precautions, such as using Google to reach websites. Google constantly scans the internet for malware. Before a user clicks through a suspected malicious site, Google gives a warning message on search page and presents a challenge page to further persuade the user to avoid the website. Solutions such as Firefox extension, no script are too all or nothing to effectively dissuade the users from unsafe surfing behaviors. No script stops the web page scripts by default, requiring user permission to enable them on each web page. After some experience, many users will be able to script anywhere, or at least on many top 100 websites where the biggest spyware threats are residing. The next type of templates, unpatched applications. Anti-pattern name is unpatched applications, also known as vendor-specific updates, default configuration, refactored solution names, patch management, unbalanced primal forces, management of integrity, anecdotal evidence. Most new attacks are going after applications, not the operating systems. Something to know about unpatched applications are patches are the software updates that repair known defects. All defects are potential security issues, given the likelihood that a defect in one part of the software could affect any other part of the system. Many of the defects in the patch updates are security related ones, either discovered by the vendor or external security researchers or from the malware caught in the wild. With the automatic updates from the operating system vendors, let it be Microsoft or Apple, operating systems and the same vendor applications are relatively well patched. The same can be said for the enterprise patch management solutions from companies like BMC, Altrace, and HP, which are widely deployed in large corporations. Patch management in many government organizations are done manually. The worst case of this anti-pattern is when the systems with default configurations are put on production networks. This applies at the operating system level as well as to the installed applications. Often, applications are deployed with helper systems such as backup servers and staging machines in default configurations. Because of all the security focus is on the production systems. Without patching and security hardening over time, Publicly announced vulnerabilities and published exploits proliferate, making the systems increasingly insecure. Anti-pattern solution. Unpatched applications are one of the biggest security risks. Add-on applications such as QuickTime for Windows, Acrobat, Chrome, and many others are frequent sources of security warnings from the United States Computer Emergency Readiness Team. Vendors try to release the patches for the problems at the same time that the defects are announced. The lag between the patch release and the installed update creates the vulnerability window for the attackers. Announcement of vulnerability and binary patch gives the attackers clues about how to exploit the weakness. Eventually, security researchers may even release the exploit publicly. Science found that enterprises are very effective at keeping operating system patches current, but they are ineffective at keeping the application patches up to date. Next, we have causes, symptoms, and consequences. The causes, symptoms, and consequences of this anti-pattern include automatic update disabled on any application where it is available. Never visit the vendor websites to search for updates. No inventory of applications and vendors. No update maintenance schedule. Not reviewing the US CERT bulletins. No governance of application versions. In the next field, we have known exceptions. If the software product support has expired and there are no further vendor updates, migration to a supported version is strongly recommended. Each organization should maintain a list of approved standard versions of all the software applications. Some vendors will continue to support the product with security patches for an additional fee. Then we have refactored solutions and examples. A first step towards managing your patches is obtaining an inventory of systems and installed software packages. On small networks, you can be able to automatic updates on the Windows and applications such as Acrobat and Firefox. For other applications such as video drivers, you might have to update from the vendor's website. So keep a track on the US CERT bulletins. If there are serious vulnerabilities announced for your applications, follow the patch available links and install the patches. In some environments, sophisticated users can maintain their own systems in this manner. For larger networks, patch management tools can maintain hundreds or thousands of machines with minimal effort. Some best-in-class vendors of these technologies are BMC, Altrace, and HP. For even greater assurance, many shops are adopting vulnerability scanning tools such as Retina from EI, Nessus from Tenable, and so on. Tools are often used for security certification testing prior to system release. Some can be configured for automatic scans, such as quarterly or daily. Tools can check for patches, policy configuration issues, and network vulnerabilities. In the next field, we have related solutions. Some technically advanced organizations are using their data center provisioning environments to assure patch management and policy configurations. By creating lockdown standard system images, data centers are able to deploy virtual servers which conform to security baselines and perform mass updates to these configurations to apply patches and other changes. The next template is never read the logs. Name of the anti-pattern is never read the logs, also known as guys watching big network displays miss everything. Insider threat, advanced persistent threat, network operation center, refactored solution names, advanced log analysis, unbalanced primal forces, management of confidentiality, anecdotal evidence, Nick Leeson at Barings Bank, WikiLeaks, Aurora cyber intrusions. We have anti-pattern solution. Network operating centers (NOC) are facilities with large colorful displays of system and network status. System, network, and security devices send messages about events, that is audit logs, to centralized management applications which test for alarm conditions and generate the big displays. The alerting rules are usually set to eliminate false positive alarms. For example, Intrusion Detection System (IDS) rules and Intrusion Prevention Systems (IPS) that cause false alarms are disabled. Frequently logged events such as configuration changes on end-user systems are not alarmed. All this is fine and good, assuming that it is actually works. But those colorful displays give a false sense of security. Is logging really working? Often, when you look at the logs, you find that it is not. Disabled IDS alerting rules introduce vulnerabilities for the attackers to evade detection. Are security devices really working? If there is an insider threat or advanced persistent threat (APT) making massive data transfers at unusual times for unauthorized purposes, would anyone notice? In the next field, we have causes, consequences, and symptoms. The causes, symptoms, and consequences for this anti-pattern include nobody responsible for reading network, system, and security logs. No health and status monitoring of syslog events. No alarm rules for Windows configurations. New IDs yield numerous alerts. Many IDs rules disabled. In the next field, we have refactored solution and examples. Reading the logs is an essential periodic activity. Without it, you will miss a lot of unusual, suspicious, and erroneous activity on your networks. Depending on the criticality of the applications, it might be necessary to review the logs daily or multiple times throughout the day. Review the system security event logs, system logs, network device logs, and IDS and IPS logs regularly. Do not always depend on the version in the centralized log manager, but periodically audit the local logs and make sure that they are accurately reflected in the central logs.